make a mistake not aware of the consequence behind. I want you to make educated mistakes. Okay. Things I'm talking here is pretty standard, so if you know what I'm talking about well, you can make a comment in Slack, and maybe others can ask you questions on that. So I will not be offended if you say you already know the stuff. While I'm talking, I also invite you to think of an instance that you can relate it to in your past experience, and that could have solved your problems. The coding rule is not specific to any programming language. So here, obviously, you already add me on Slack. Go to this link on Google Doc. This link is already in your. Let me also copy that to Slack. So let me just copy that on Slack. Okay. I know some part of you might have Google banned. In that case, you can do the activity here on Skype, here on Slack. But otherwise, if you have access to that Google, you should. Okay, so everybody just find a spot on here. Find a spot on here. Write your name. Write your name and use open, close curly bracket to secure a space for yourself. I want to see everybody doing the coding in real time. Good. Do you still see the slide? So here's our first exercise: add code, change code, which includes a specific and very common change code called rename, delete code, find code, and start all over. Start the project all over. I want you to rank the difficulty of these activities, and I will give you a hint. Start over is the hardest. Change, add, delete, find. That includes rename. Don't forget there is an option called rename. Make rename a separate one. Now let me give you my guess to it. I'm not saying this is the absolute correct answer, but based on my experience, I would rank them like this. Start all over is hardest, of course. Then it's delete code. No, delete code should come second. Change code, delete code. Because there are rarely reasons to delete code, but if you really want to delete code, that's actually pretty hard. Then it is rename should be one of the easiest. Not the absolute easiest. Find code. If you really name your code, structure your code very well, you can easily find code. Add code. Okay. Does everybody see my ranking? And do you have any question for me? If you have any questions, you can either unmute and say your question, or you can type your question on Google Doc and highlight it in yellow so I can see your question. If I don't see your question, I'll assume you just agree with my ranking. Okay, seems like nobody has questions, so I'll assume you agree with my ranking. So that brings up to a very interesting point. Changing the code is actually the hardest. So we should really optimize our code in a way that makes changing code easy. Okay, I know you all can write code. I mean, that's why you go to college for that. You should be able to write any code you want. Otherwise, you have big trouble. So I'm not challenging you to write code well. Rather, I'm challenging you to write your code in a way such that it is easy to change later. And this entire orientation will be all about some systematic ways to framework your code in a way such that it is easy to change later. It is all this orientation is about. Okay, but that sounds like an easy thing to say, but that's actually quite hard to do. It's like, what's the one way to solve all your problem? Okay, the one way to solve all of your problem, most of your problem, is actually get rich. Okay, that's the one-word solution to all your problems. But that doesn't mean you should follow it directly, because there's no way to follow it directly. So there will be some systematic way to do it specifically, and we will continue on. Okay, we'll go to the next slide. Okay, coding efficiency or rather inefficiency. So this is a differential equation. C means how many lines of code. C is how many lines of code you write, and T is time. So the left term on the left of equal sign, it is dc dt. It's the efficiency to increase your code. The efficiency to write more code. It is proportional, or rather inversely proportional to the amount of code you have. Because the more code you write, okay, the more code you need to worry about. The more code you need to make them consistent. So your efficiency is actually inverse proportional to the amount of code you write. Does anybody have a calculus genius to solve this equation for me? Anybody? Okay, that's not a concern of this orientation, but if anybody happens to want to do it, then you probably don't know how to solve this differential equation. So given this differential equation, the solution is C, how many lines of code, is square root proportional to the amount of for the time. So actually, so if you write, giving that a short analogy, so if you write, if in one day you write 10 lines of code, one line of code, then in 100 days you only write 10 lines of code, or 10 pages of code. Yeah, if you use one day to write one page of code, 100 days you only write 10 pages of code. That's horribly inefficient. So we really don't want that kind of inefficiency. So in the ideal world, we don't want this to be inversely proportional to C. We want it to be a constant. So dc dt should be some constant. The constant might have a smaller coefficient, for example, 1% of a constant, very small. But in the long term, that will pay off. On the other hand, as you can already see, if you are working on a small project, maybe one page of code can do it. You shouldn't follow what I say, because that will slow you down instead. So if you're doing a homework, like that, like one day you can finish, don't follow what I do, because that actually makes you slower. But since we are making a big project, you should follow what I tell you. Okay. So this is how much time you spend on reading your own code, versus how much time you spend on writing your own code. Some expert did the analysis. The ratio is 10 to 1. 10 to 1. So you spend 10 times more time to read your own code versus write code. So you should really make your code easy to read, not for somebody else to read, simply for yourself to read. So yeah, so that's basically, you are doing it for yourself. You are not doing it for other people. Okay. Okay, so the next slide. Can you all see my slide? Okay, if you don't say anything, I assume that's yes. Okay. Here are some things about naming your code. Okay, so every abstraction deserves a name. Any concept that you can give it a name, basically, any concept that you can give it a name deserves a name. Okay. If it's reusable, especially if that concept is very reusable, that deserves a class by itself. Okay, it doesn't matter if that class is doing the job of a function. Maybe you are writing a class that's the only purpose is to be like a function, but if it's reusable, it deserves to be a class. Okay, so here I give you an example. There is a static function, static tool that push nail. Okay, that's the job. The job of the function is to push a nail. It shouldn't be a function. If it's very reusable, you can really expect other people to use it. So it deserves a class to be called a hammer. Okay, somebody can give me maybe another analogy they want to use. Will somebody give me a analogy they want to use? Okay, maybe no. Okay, so the counter example, what you should never really do is to poorly name your code. Okay, no PPP, GGG, X, Y, N, ABC, no such thing. No such thing. I should never see such things as a name of your function or class. Okay, unless you are doing something that's really called X. Okay, maybe you are doing E equal to MC squared. Okay, then in that case, E is perfectly legit. But unless you are doing that kind of thing, name your thing clearly that is understandable. Okay, understandable. Other people, you can understand it, and other people can understand it. So some suggestions: if that's a quantity, name it with units. Okay, don't say get time. Okay, get time in seconds. Don't say get length in centimeters, meters. Okay, get whatever, get weight in pounds or kilograms. Okay, if your function has any side effect, okay, reflect that in the name of the function. Okay, can somebody give me an example that they have did that they created a function that has a horrible side effect? Can somebody give me an example they've done? Either write it on your Google or unmute your microphone and speak to me. Okay, so Alice gave me a very good example. If you want to do some large computation, some NP computation, for example, that might takes up a huge amount of space. You better let other people use your function and be aware of it. Otherwise, people might think that's a O1. People might assume that's a O1 operation when it's really ON or ON squared. Okay, in that case, you should really reflect that in the name so other people can see it directly. And in contrast, rather surprisingly, and some of you might disagree with me, I don't want you to write comment. No, I know people have told you to write comments, and I'm telling you the opposite. Don't write comment. And this is not to say don't write comment in a naive way. It's don't write comment in a sophisticated way. Okay. Because first of all, why you shouldn't write comment? First, do you read your comment? Okay, probably you don't. Okay, does the person use your code to read your comment? They are probably also too lazy to read your comment. Does the compiler read your comment? Okay, so definition of the comment is the compiler doesn't read your comment. So when nobody is reading the comment, why do you write comment? Okay, later we will see that actually comment is a violation of the DRY principle. don't repeat yourself principle. So when we get there, I want you to tell me why comment is a violation of the DIY principle. So rather, I want you to, whatever you say in the comment, I want you to rather to name this thing directly, okay? Because later you might change. Okay, a more horrible thing is later you might change your function, you might change your real code, and you forget to update your comment with it. Okay, then that becomes a horrible misconfusion. Okay, you might say this is apple when you might comment this is an apple when it's really an orange, and the person reading your code, maybe yourself 10 years later, or maybe another your coworker, is going to be totally lost on what you're doing. So that's a obvious, that's a horrible side effect of the violation of the DIY principle. Don't repeat yourself. Okay, so you might end up with a very long function name. That is totally okay with me. I want you to be clear than be concise. Okay, there's very limited advantage to be concise, especially with modern IDE. It has auto-completion. It's 10-word function is as convenient as the 3-letter function. So the length of the name given with IDE doesn't provide any much advantage. Rather, the clarification is very important. I know somebody wants everyone's method in 5 lines. Yes, I want your method in 5 lines. That's not a hard demand, but that's a rule of thumb. So there is no need for comment. I don't think it is a rule. I don't. Tom, okay, explain. Speak, Tom, speak. Hello, Tom?
Yes.
Explain.
Yeah, I know somebody want everyone to write their message in 5 lines. So it would be very easy for everyone to understand their method. So there no need for comment.
No. Think of the name not as a. Think of the name as another summary for your 5 lines. So your 5 lines is already clear. Good, I like it. Make the name a summary of your 5 lines. Did I answer your question like that?
You mean method name is a summary of that 5 lines?
Yes.
Yeah, I agree.
Okay, so let's move on with the next slide. By the way, in the contrast, what will happen? Sometimes you find it hard to name a thing, to give an appropriate name to some function or class. Then you violated some principle. We'll get to that. Okay, you should always find it easy to give it the appropriate name. So if you find it hard to give it the appropriate name, you did something wrong. We will get there. Okay, so the most important rule of all rules is the DIY principle. Don't repeat yourself. Okay, don't repeat yourself. So here's how I define it. My definition, not everyone's definition. If you are changing one problem, maybe there's one bug, or maybe not bug. If you're making one modification for one purpose, you should change only one place in the code. If you need to go to several different locations of the code, especially in multiple classes, to change your code, that's certainly a violation of the DIY principle. So one most common cause of that is you copy your code. You paste your code into multiple places. Now, of course, every time you change it, every time you need to change it everywhere. So So OOP is basically invented to avoid copy and paste. OOP gave you such an elegant structure to avoid copy and paste. You should take advantage of that. Never copy and paste your code. Never. You can cut and paste. That's okay. Never copy and paste. Okay. So, yeah, that basically makes the change horribly difficult. Any questions? Then I see that's no question. Okay, solid principle. That's basically the golden principle of OOP. Solid principle. The first principle of all principle is single responsibility principle. Every other principle builds on top of it. Single responsibility. One class should only do one thing. One class should only have one responsibility. Okay, if one class has one function, one class has only one responsibility, why would you ever find it hard to name it? Do you get me? Okay, if you find it hard to name it, if the name is horribly long, it's probably doing 2 things or 3 things or 4 things at a time. Okay, then you should further break it down to even more classes that even more classes that just doing each job separately. Okay, then you can package them together into a super class, but the super class basically doesn't have any real code. So super class, the only purpose of a super class is to group everything together. Okay, the super class, that's in that sense, the responsibility of that super class is to group everything together. The responsibility of the super class is not doing anything other than that. Okay, so think of it as a person. Okay, that's my favorite analogy. I have a subclass. Not subclass. I have a class head. I have a class hand. I have a class foot. I have a class body. Okay, they have their own responsibilities. Okay, as the person class, I simply put all of them together. Okay, that's the responsibility of the person class. Okay, the hand has a responsibility to grab. The foot has a responsibility to walk. The eye has a responsibility to see. Okay, they do their own thing. As a person, I'm like the boss putting everything together. That is my responsibility. Okay, any questions? Okay, no. Okay, because that's very important because every other principle builds on top of the single responsibility principle. Okay, so open. Okay, that's S, single responsibility. O, open close principle. Open for extension, closed for modification. Okay, as in the first exercise, I already said changing code is the second most horrible thing to do other than starting all over. So you try not to modify code as much as possible because every time you do that, you bring unnecessary risk. So a class should be closed for modification, but open for extension. Okay, in OOP that's called inheritance. So you can inherit a more specific class and override some of the function, override the code of the parent class. In that case, you didn't change the parent class at all. The parent class, you don't even need to open the file of the parent class, but rather you override the code in your parent class without changing the parent class. So that is called a virtual function. You override a virtual function. And the close for modification should be something you're already familiar with. That is to make your variable private. Don't let other people touch your variable unless you have a very compelling reason, which I don't think you will ever have a compelling reason. So in C#, you have a huge advantage for the open-close principle because C# inheritance is always overridable. if you're familiar with C#, you know what I mean. L, the L of solid, L is Lipschitz substitution principle. That says a specific instance should always be able to replace the general abstract instance. Rather, I want you to understand it in the reverse way, because inheritance is a given property of OOP, and there's nothing hard about it. Rather, if you find the instance, the child class, the inherited class, cannot replace the parent class, then you used inheritance in the wrong way. Okay, then you use inheritance. It should be something else that's not inheritance, and you misused inheritance. So one example of that is like this. So again, the person class. Okay, the person class has a hand, and I use the person class to inherit. Please mute your mic if you are making a noise. Mute your mic. Mute your mic. Mute your mic. Mute your mic if you are making a noise. Hello? Good. Okay. For example, maybe. Oh, let me give you a better one. That's my favorite example. So there is the constant pi 3.14 thing, and there's a class pi of that. Okay. Now there is a circle class. The circle area equals pi r squared. That thing. Okay. In the circle class needs to use the constant pi. But the circle is not pi. They're horrible. They're different things. And somebody inherit pi with circle, just so that they can use pi. Okay, don't do that. In this case, the circle is not a substitution for pi. Okay, just because you need to use something, it doesn't mean you should inherit it. Okay, there are better ways to do it called injection, which we will get later. So if an inherited class cannot replace the parent class, you misused inheritance. Okay, I is called interface segregation. So many separated specific interface are better than one super purpose interface. Here I gave you an example. I speakable with I listenable, with I walkable, with I thinkable, with I makeable. All those interfaces separated is better than one super interface called I person that has all those capabilities. So if you can if you can go to Google Doc and see my my part of the code. I person. So without the proper way to do it, without violating the dry principle, is like this: I interface I speakable string speak. Okay, that's my speakable interface, and the other interface you can imagine. I'm not going to waste time on that. And here I do the super person interface, which is the person interface inherits I speakable, I listenable, I walkable, and here you write nothing in here. Okay, I know I just said don't use inheritance just because you need it, but interface is a different story. So interface is not really a class, so that doesn't apply. So you can do inheritance with interface like this, but for real class don't do this. So, okay, so the last principle is actually dependency inversion. Big picture stuff should not depend on the detailed stuff, okay? The president doesn't need to know you, okay? That doesn't mean you are useless. You are you are a valuable part of the program, okay? But the president need to manage high level things, and the president should not know a particular thing. So here example, the president need to sort all of you, for example. The president just need to know something that can sort. Maybe the secretary of the energy department can do the sorting. But the president shouldn't care whether you are doing a merge sort, a bubble sort, a quick sort, a heap sort. The president shouldn't know such detailed thing. The president only wants to need to know something that can sort. Okay, how the specific implementation of sort, the president should not know. That means if you're writing the code for the president, you should never reference bubble sort directly. You should never reference merge sort directly. Rather, you just reference a general sort, and the bubble sort implement the sort. The quick sort inherit the sort. You know what I mean? Okay. So what's the consequence if you violate this? That makes your code really hard to change, because once you write the code, you make the president call bubble sort. Once you write that code in the president, then the president is locked into bubble sort. The president must use bubble sort. If you write the code quick sort in the president's class, then the president can only use quick sort, or the inherited stuff of quick sort, which is also quick sort. So you are making specific decision too early. That makes later change difficult. So never. One, it's saving you the brain cells to think too much. Don't think too much. And second, just don't think too much. Okay. One way it saves yourself the effort, and one other it's making the code easy to change later. Okay, so that is the solid principle. I want you to take a moment, review all five of them. Take a moment, think again, because later we will go to some specific examples, and I want you to point out which one of the principle my example violated. So take the time, think again, ask some questions, and let me know if you are all ready to move on. Okay, dependency injection, which I think is the greatest invention after OOP. Okay, dependency injection, that's a brilliant idea. Once I see that idea, I fell in love with that idea. Okay, the idea of dependency injection is super simple. Ask for what you need. Okay, again, it's making yourself easy. Okay, ask for what you need. Don't do it yourself. If it's not your responsibility to do it, don't do it yourself. If you're doing it, you probably violated the single responsibility principle. Okay, unless that is your responsibility. Of course, in that case, do it yourself. If it's not your responsibility, you only need to use it. Don't do it yourself. Ask for help. Okay, don't create it. Don't create the object. Okay, creating the object is actually another responsibility. Okay, can somebody give me the name of that responsibility? It's a design pattern you should all be familiar with. What's the responsibility to create object? Come on, you should know this. Anybody? Anybody? No, it's not that hard. What's the responsibility to create object called? Really? Nobody? Take a guess. That's a design pattern you should learn. Constructor? Close. Constructor. Sure. I gave you half of the points for that. Constructor. Good guess. Any other guess? Okay. Factory. Anybody not know factory? Make a noise if you do not know factory. Okay, now I'm confused. You don't know the responsibility to create object, and you all know factory. Are you too shy, or anyway? Let's move on. Let's move on. We don't waste time for that. Okay, if you are creating objects, you are doing the responsibility of a factory, and you violated the single responsibility principle. And don't look for it. Don't even look for it. Don't go to look for it. Don't create it. Don't look for it. If you're looking for it is the job of some like a dictionary lookup. You're again violating the single responsibility principle. Okay, just ask for it. Okay, ask for what you need. That makes your thinking easy. That makes your job easy. Give the shitty work to other people to do it, and you just ask for it. Okay. And that goes along with it is the law of Demeter. So, single dependency injection says ask for what you need. Law of Demeter says ask for only what you need. Nothing more, nothing less. Ask for only what you need. So later we will have an activity on this to illustrate the importance. But now let's just go on. So dependency injection, okay, how do you really do dependency injection? There's no other magic. Okay, go to my part of the Google Doc and scroll up and go to my part of the Google Doc. Okay, there are 3 ways to do dependency injection, and that's no magic. You all know how to do it. Initialized by constructor. Okay, I have a class person. Okay, again I'm using a class person as an example. Okay, and there is a class hand, which I don't bother to implement. Okay, so a person class has a hand. Okay, in case you don't know the naming convention, the capital hand is the class type hand. The lowercase hand is the variable name hand. It's just a convention that you use capital C# convention. Why do you use convention? To use the capital for the class and the lowercase for the actual instance. So if you don't know the difference between a class and a class instance, you should go to review it, but otherwise I assume you know it. So a person contains a hand, right? I have a hand. Let's say I have only one hand, make it easy, okay? I don't create a hand. No, I don't create a hand, and I don't call the constructor create a hand. I don't make a hand myself. I don't look for a hand. I ask for a hand. How do I do it? Public constructor person constructor hand. Okay. Sometimes we put an underscore for the variable to indicate that's a private variable. Okay, does that look easy? Ask for what you need. Don't do this. What you shouldn't do is this. What you shouldn't do is you shouldn't do this. I know other people probably touch you to do it like this, but I'm saying otherwise. Don't do it. Don't create a hand. That's for the job of the factory, because the creation of a hand might be very complicated, and you are Now you just coordinate constructor. What if you need to give the hand some ID that cannot be, that must be unique for each hand? Now how do you do that? For example, every hand that's created must have a unique ID. Okay, that means there has to be some central ID management, which obviously the person should know nothing about the ID management. Then in that case, you're making the creation of the hand difficult. Okay, you shouldn't do that. Okay, that's called initialized by DI by constructor, and there's a DI by setter. Okay, pretty much exactly the same as the constructor one. Can somebody tell me the pros and cons of the two versions of the dependency DI by constructor and DI by setter? Somebody speak. Unmute your mic. Speak. What's the pros and cons of each? There's no better one. There's a preferred one. I'm not telling you yet. There's no absolutely better one. And pros and cons, take a guess. Okay, then I will leave that. We will go through an exercise on this, and that will become clear. Okay, and there is another DI method called by framework. It's basically like this. So let me comment out this. Maybe not. Let's do two. Okay. So basically, you label the variable hand with inject, and the framework will look for such a label and fulfill that variable, initialize that variable for you automatically. Now you will get to learn that later in actual work, but here I'm illustrating the three approaches to do dependency injection. The advantage of the first two is that you don't need to rely on any framework. That's already a part of the coding structure. Constructor is already a part of the coding structure. Setter is already part of the coding structure. You don't need to rely on any DI framework. And the advantage of the framework one is that the framework, although you rely on the framework, but the framework makes your life really, 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 really easy. Okay? Okay, we will get to the difference between the constructor and the setter one, because I don't want to spoil the answer for our later activity. So we will come back to the difference of the first two. Okay. The best function in OOP. What is the best function on OOP? It's void some function with no parameter. Void some function with no parameter. No input, no output. That is the best function of OOP. That's ideal. That's an ideal function. I'm not saying to make all function like this. No, I'm not saying that such thing. If possible, make it like this. But if it's not possible, there's no reason to absolutely enforce that. Why? Think of it like this. So okay, so you have a function. What if you say you have a function with one variable? What if later, if this one variable is possibly later you might change that to two variables. You might later change that to three variables. So what happens if you change the function signature? Okay, every time you change the function signature, you change it one place. All other parts of the code become not synchronized. Okay, now the compiler no longer recognize this function because you change the function signature. So that becomes a nightmare. You need to go to all other places that cause this function to change all those codes together. Okay, that's an easy thing to do, but that's a tedious thing to do. That slows down your efficiency. Okay, but if there's no parameter to begin with, no problem. If no parameter to begin with, you probably never need to add any parameter. And the same idea for the return. If there's the return is no return, then you'll never need to change it. Okay. So I got a question. So it is reusable. Yeah, it is reusable. Okay. Okay. Now exercise. Oh, so okay. So go to the Google Doc. Go to all the way to the bottom. Go to all the way to the bottom. Go to the bottom. Go to the bottom of the page. Start another. Just do it like before. Start another. We are moving to another exercise. Just go to the bottom. Don't write down my code. Okay, do it again. Create a space for yourself. Okay, here is the exercise. Write a class for soldier and write a class for president. Don't implement it. Just write a header. Just a header is enough. Something like a header. And the soldier needs to report some important military information to the president. Okay, that's all you need. Should take no longer than 1 minute. Write your code. Okay, if this helps thinking, okay, just to help you think. You don't actually need to write it, but to help think. There is the password. The soldier has it. Okay. How do you give this password? Okay, so the president also has a field called a variable called password. It's now. The president has a variable password currently in now. Okay, what's the actual password? The soldier has it. How does makes the president the password variable not now to be the actual password? Okay, that should help you think. Otherwise, you're making it way too simple. Oh, can I say that again? Password. So let me write it. Class soldier. Okay. String pass equals 1, 2, 3, 4. Oh, fine. Okay. Okay, that's the string soldier. Class president has a string pass now. Okay, help me to assign a value to the president's pass variable. Okay, if you don't understand my question, just go to my part of the code, and you should see what I mean. Just screw up to my part of the code, and you should see what I mean. You don't need to implement your class, but the logic should make it possible. Okay, so I want you to draw your attention to Tom's design and Yiming's design. So in Tom's design, there is a soldier in the president, and in Yiming's design, there is a president in the soldier. And I want you to comment which design is better and why. Why? Which one's better? Why?
Yeah, I think mine is better.
Who are you? Who are you?
Tom.
Yours is better? Why?
Yeah, because I think there might be many soldiers in the future. Yeah, so if you just store the present in the soldier, it's not that reasonable.
Okay.
I actually think Hong Yu's design is better.
Okay, who's?
I'm speaking.
Who are you?
Ricky.
Okay, which one's better?
I think Hong Yu's design is better.
Who?
Hong Yu Yang.
Oh, okay. I haven't looked at hers yet, but.
Oh wait, what? Sorry, oops. Sorry. Yiming. Sorry,
Okay.
Yiming's
Yiming.
design is.
Why?
Because. Oh wait, hold on. Is Yiming editing his code?
I don't know. Just go with what he has now.
No. I think it should be a soldier class inside the president class, because the president can have some property that's borrowed from the soldier class.
So the president can do something to
that
the soldier.
can do,
Okay.
and the president can do something something else that the soldier cannot do. But it should be like, I don't know. Like, I think it's more inclusive.
Mm-hmm.
Yeah. So I think the soldier class should be inside the president class.
Okay, soldier in president.
Because the soldier, if there's a president class inside the soldier class, I don't think that makes sense.
Mm-hmm.
Because a soldier shouldn't carry property of a president.
Okay. The soldier shouldn't carry a president. Okay. Any opposite opinion? Everybody thinks there should be a president in the soldier. Anybody?
Well, I think there should be separate, because only the president.
Oh, who is speaking again?
Yimi.
Oh, you mean okay? Well, go on.
Because we only asked the soldier to know the president, but the president should not care whether a soldier is what are his names. It doesn't matter. It's just every soldier must know the president so they can report to the president. But the president don't need to know the soldiers. So that's what I say.
Okay. Anybody else thinking like Yimin? Or anybody else thinking like Tom?
Okay, I'm Tom.
Okay.
I think that depends on what you need. If you want the soldier send the message to president, the president should carry the soldier. If you want the president send the message to the soldier, then maybe the soldier can carry the president. So in this way, I think the president should contain the soldier.
Actually, to answer your question, for your particular question, as long as one knows the other, you can exchange information two ways. So in that regard, it doesn't matter. As long as one knows the other, you can send the message forward and back. So in that sense, it doesn't matter.
Okay.
Anybody else want to express an opinion? Okay, before you speak, say your name so I know who you are. But anyway, at this point, there is no right or wrong answer yet. Okay, no right or wrong answer yet. But according to one of the solid principle, naively according to one of the solid principle, there is a right answer. And can somebody tell me which principle it is? Dependency inversion. Let me give you a hint. Dependency inversion, and somebody tell me why.
Cox Wi-Fi.
But let me tell you why the dependency inversion is dependency inversion. Because the big picture stuff is less likely to change, whereas the detail implementation is more likely to change. So you should really make something depend on don't depend on something that's likely to change. Depend on something that's less likely to change. Because when you depend on something more likely to change, you have more likelihood to change your code. For this example, how many presidents are there? 1. Okay. How many soldiers are there? 1. Okay. But which one do you think will have more in the future? There will be more soldiers in the future. Okay. So if the president knows the soldier, now we have a president have 1 soldier. Now, if there are more soldiers, then you need to make the soldier into a soldier array. Okay, you are changing the soldier to a soldier array. That's already changing your code. In contrast, if you make the soldier know the president, there's almost always going to be only 1 president. So even if I create multiple instances of the soldier, I don't need to change any code, right? You think the president is still the 1 president. I don't need to change the president into a president array. Okay, now the story changed. Okay, now the president got assassinated. What do you do? Change your code accordingly to accommodate this. So in other words, you cannot use the president class anymore. The president object become destroyed, become garbage collected, and obviously I'm not allowing you to create another president, and that defeats the purpose. Things can happen, right? The president can be assassinated. The president died. What do you do? The soldier still needs to report the important, time-sensitive military secret information to somebody, right? They are in a war, and it's important. Okay. Meanwhile, let me make a comment. What's the real life significance of this kind of thing? For example, you did your plan like originally with the president, but when you deliver your product to the hands of the customer, the customers are unhappy with this president, and the customer said they want something else. Okay, the customer is our God, so whatever the God says, well, we need to listen, right? So that's the real life implication of this scenario. I'm seeing Andy is being clever on this. Okay, who thinks they have a good solution on this? Okay. Andy, are you online? Speak to me. Can you explain what you did?
Well, I'm using an interface, so it is open for extension.
Okay, good. You are following the open-close principle via interface.
Yes.
That's good. Okay, does anybody have any question? Or somebody can make a suggestion to make that even better? Yeah, let me hold on to that yet, because there are more questions. There are more questions coming on. That's going to use that part. So, okay, let me move on to the next slide. Okay. So somebody suggests to the soldier to report to the president. Actually, last time Ricky suggested, since the president died, why doesn't the soldier report to the vice president? And but the problem is that you already hard-coded the soldier to report to the president. If you want to give it a vice president, the variable type doesn't match. The compiler won't compile, right? So one solution to that is actually to let the president inherit from president. Then, because the vice president inherits the president, it becomes a subclass of that, and therefore you can use a subclass to replace a parent class, and that way the compiler won't complain. But should the vice president inherit the president? Somebody speak. Is that a good decision? And is that a good decision?
I think it's not, because the president can do something that the vice president cannot do.
Okay, who is speaking?
Amanda.
Okay, good. That's the perfect answer. The president has the control of a nuclear bomb. The vice president certainly doesn't. So if the vice president inherits from the president, the vice president will also have the power to launch a nuclear bomb, and we don't want that to happen. So basically, Andy's solution is almost already the perfect solution. Okay, go to next slide. Okay, next slide. So in Yimin's approach, you gave the Yimin's approach, you gave the president to the soldier, right? You gave the president to the soldier, and say the president has a function called kill. Okay, well, I don't want to eliminate the function called kill, because I really want to have some control over the president. What if the president become a dictator? Okay, I want to maintain control to that. So basically, what I want to do is private the president that kill to class soldier. So when the soldier sees it, it's private. But when, say, there's a class called God to punish this dictator president, the president that kill is public to the class God. Okay, and how do we do that? This is not part of the language directly. There's no syntax called public to only class God. There's no private to soldier. There's no such syntax to do that. But I really want to do this, because that's important. It's important for the security. I want a God class to be able to kill the president when the president becomes a dictator. But I don't want a trivial soldier class to have control to that. Otherwise, it's too dangerous. Actually, giving you a story on this. Okay, does anybody know what's the world's most expensive stock? Any idea? Kyle, you are working on this.
Bitcoin.
No, real stock.
Amazon. Amazon.
I think now, yeah, Amazon. But I think now it's Amazon. But when this instance happens, it's actually Apple.
Oh.
Okay. When the story I'm talking about it happened is Apple. So what happens is that at there's one moment, Apple was no longer, for 1 second, Apple was no longer the world's most expensive stock. Just for that one moment, there is a stock, I think that's 100 times more expensive than Apple. Does anybody know this instance?
I read that story, but I
Yeah, there's a story on this.
a Chinese.
There is a stupid finance trader. He put too many zeros on the market order, and he purchased he purchased a huge amount of some stock at an unreasonably high price, and that boosts that stock to skyrocket, become the wrong unit. Okay, wrong unit. That skyrocket basically that becomes the most expensive stock in the universe. Okay, and why that happens is I'm giving such people too much power. Okay, it's the same idea to give the kill. It's the same idea to make the kill function public to the soldier, right? If the soldier doesn't, if the kill is private to that soldier, this could never possibly happen. So I know you are writing the class, you are the programmer, I should put trust in you. But if I can just make it private, and you will never theoretically be able to do wrong things, that's a better way to manage people than just trust them to not make mistakes. So anyway, back to the answer. Is the way to do this? Make the president.kill private to the soldier, but public to the god. Okay, unmute before you speak. Okay, I would not actually expect you to know the answer, but I do want you to take a time to think about it, so you can appreciate the difficulty. So go to my part of the code. I will show you the answer. Just scroll up to my part of the code, and I will show you the answer. Okay, did you see what I do? I first create the interface iQable with the function kill. Okay, and I'm going to change Andy's code official. First, for C# convention, you start the interface with I to indicate that's an interface. It's not necessary. It's not absolutely must be like this, but stay with the industry convention. Another good practice is to make interface something able. Means it's able to do this. So it should be a verb able. It should be a verb able. Somebody want to give me a appropriate name for this? It's not that hard. Grace, the CNO. What's the appropriate name for this? Okay. Let me put this into the. Okay. Here's the solution to that problem. Okay. Here. Andy's original solution is interface official, but I said to make it start with I. That's a convention for interface, and something able. It means the interface is able to do this. So, what's a good name for this? Okay, I'll give you 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I'm giving you the answer. I receivable. Is that so hard? I receivable. Okay. If this is not clear, you can say I password receivable to make it clear you're receiving the password from the soldier. Okay. But for now, I think that's good enough. Okay. So I have an interface I receivable, so the vice president can also implement that. And then I'm going to create an interface I president. Now this is a good one for I official, which implements I receivable and I killable. Okay. Now I have the nothing in here again. Really, I put nothing in here. I simply inherit from I receivable and I killable. That makes it I official. And obviously both the president and the vice president can implement the I official, right? But stay with the old one, so let me remove the I so we can be consistent. So now we have I receivable, I killable, and we have an official doing both. Okay, and the president code is exactly perfect. The vice president code, you know the idea, so I don't need to do anything to that. Okay, we say we want to add a class to a of a God, right? God is God. God doesn't need to inherit anything. Okay, God. Let me use the shorthand notation for this. Inject. So later the framework will inject official automatically. Okay. Now we need to change the soldier. Okay. This goes back to the law of Demeter. Ask for what you only need. Ask for what you really need. Okay. The soldier doesn't really need the president, as we discussed. If the president is dead, the vice president is perfectly okay. Okay. If the vice president is dead, maybe some like general is perfectly okay. Okay. So the soldier doesn't even need official. He doesn't need to be official. I receivable. Make it a list. Somebody move your cursor. Somebody move your cursor. Listener. Okay. Yeah. Do you see how I solved this problem? I never gave the soldier the capability to kill. I never give the soldier the capability to kill because the soldier doesn't need somebody who's killable. The soldier only needs somebody who is able to listen. Right? Anybody with an ear should do the job. In contrast, the God class injected official because I do want the God to be able to both to listen. The God can do whatever he wants. The God should be able to listen and to kill the president. But obviously you also observed. You could also do this if the only job for the God is to make sure the president doesn't become evil. You can do this, right? If God doesn't want to talk to the president, God only wants to kill the president if he becomes evil, you can do this. Again, ask for what you only need. Okay? Ask for what you only need. Then your code becomes extremely flexible to accommodate any change. Okay. Again, make another comment. here I told you to inject I killable and inject word to inject I receivable. You can inject president to both of them. President implements both of them. You can reuse the same president for both purpose, or you can use different president for both purpose. Dependency injection doesn't care at this point. Okay, it's the moment when you inject, you care which one to inject in. But at this moment, when you're writing this code, you don't really code if that's the same president or vice president. As long as the soldier has somebody with a ear, as long as the God has the power to kill that president, that's all you need to do at this moment. So later when you inject, you decide which president to inject, which vice president to inject, so on. Okay. So now let's go back to a question we didn't answer earlier. Here, okay. Let's go back to this question. I asked you earlier, there are 3 ways to do dependency injection: by constructor, by setter, and by framework. By constructor, by setter, and by framework. Okay, I explained the difference between the last one, but I didn't explain the difference between the first 2. Okay, well, so what's the difference between the first 2? The difference is that once you do it by constructor, it is forever that one. You can no longer change it, because I required all the variable to be private. So once it's there, it's there. You can no longer change it. Versus in contrast, where's my, okay. If you do it this way, look, once you inject the listener into it, you can no longer change it whatsoever. You can no longer change it whatsoever. So if in this case, the listener becomes a null, now you are sending message to this null, and there's nothing you can do about it. I'm not saying that's good or bad, depends on the case. Maybe in some case you really want it to be unchangeable. But in this particular case, you do want it to be changeable, because what if the person died, right? So okay, in this case, if that president become a null, somebody else can give it another, like a vice president, to avoid a null pointer exception. So that's a difference. I'm not saying which one is better. It depends on the case. In the case you really want it to be unchangeable after the initialization, use the first one. In the case you want it to be changeable for whatever reason, depends on the specific case, you do the second one, or you do both. Okay, a summary. There are 3 keywords you should be familiar with: is, has, and knows. If the relationship between 2 objects is, you should use inheritance. For example, Obama is president. In that case, Obama inherits from president. Okay, and has. Let me do a contrast. Vice president is certainly not a president. They are horribly different. That's why we shouldn't use inheritance in that case. Okay, has. Does the president has a soldier, or does the president knows the soldier, or does the soldier knows the president, or does you know what I mean? So certainly it's not a has relationship. It's simply a knows relationship, and by the dependency inversion principle, we let the soldier to know the president, and in both cases you use injection for has and knows, but the difference is there should be another slide. Maybe okay. Maybe I put a slide later. The difference is basically, if it's a has relationship, you have the control of that object, you should make it not read only. If it's a nose object, you don't have control to it, so you do want to make it read only. But it depends on the specific situation. There's no absolute right answer for this. The only absolute thing is use inheritance. If it's not an is relationship, don't ever use inheritance. Okay, exercise 2. Let's go back to your Google code. Okay, in this exercise, I want you to choose which one to write, randomly or not randomly. Select to write either the player class or the player GUI class. Okay, the player class is basically a player. Think of the Super Mario. Okay, he has a health point HP from 0 to 100. Okay, and his job is to keep track. Every time he got a bullet in his body, he lose 1 HP. Okay, so his job is to keep track how much PhD and HP he has, like whether he got hit or not. Okay, that's his job. Okay, according to the single responsibility principle, the display of that number is a different responsibility. Okay, one is to keep track of the number doing the addition and the subtraction. The other is to display it. That's 2 separate responsibilities that should go to 2 separate classes. Okay, so choose which one you like. Just don't end up with everyone. As long as you don't all choose one, I'm fine with that. Just choose one to work on. Again, just reminder, highlight your class when you are done. So I know you're done. Okay, are you done? Who is not done? Otherwise, I will move forward. Speak if you are not done. Otherwise, I'll just move forward. Okay, nobody is speaking, so I will move forward. Okay. So for those of you who did both, I want you to choose one to comment out. Because that's actually the point of this exercise. For those who did both, I want to choose one to comment out. You don't need to delete, just comment out. Okay. Did you comment out your extra one? Kyle is being fancy with player 1 and player 2. Okay. Okay. Now I don't have to delete it. Just told you to comment out. But so now let's take a look. Tom did the player, and Andy did the player. Alex did the player. Yang Yu did the player. Kyle left. He did the GUI. 啊，走了，他走了，
他走了。
他不是我那个，他是
OK
等我跟你说。Okay, Homa did the GUI. Okay, Andy, I actually want you to put your GUI back because everybody else did the player. Okay. So now here is a story. So it's actually a team collaboration. So this is actual team collaboration that you and your partner are actually working on two different things for the same purpose, right? You are working on the player and your partner is working on the GUI, and you all need to put your code together so they become complete, right? But the case is that your partner is maybe too slow. You finished your code and your partner didn't. Your partner didn't finish your code. But you cannot do anything else at this point because you need your partner code to go on, right? So now you want to test your code to see if you did it correctly or not, right? But your partner is not ready. You don't have your partner's code. So what can you do at this moment? What can you do at this moment? Somebody make a guess.
Just generate some input by myself and see whether it work.
Okay, maybe that's a very complete. Okay, here I'm making this player GUI example to be a exercise, but in real production, your partner's code is gonna be very complicated, right? It's not likely you can do both work by yourself. What do you do? Like, remember to unmute before you speak. Okay, I will. If you don't mind, I will just give the answer. Okay, just screw up to my part of the code. Okay, screw up to my part. Whoever is selecting everything, please undo it. Whoever is highlighting everything, please undo it. Okay. Go to my part of the code. Don't put your cursor there. You're getting in my way. Okay. So this is what you do in a collaboration. In a collaboration, first you need to decide who knows who. Again, just like in the previous exercise, the soldier and the president. Does the soldier know the president or the president knows the soldier? You don't have to do both. You can, but you don't have to. As long as one knows the other, you can do information passing, both two-way information exchange. So one knows the other is enough. So somebody gave me a guess. Who knows who and why? Who knows who and why? Player knows the GUI or GUI knows the player?
GUI not player.
GUI knows the player. Why?
Because the GUI need the player's information to show the output, like
okay.
the score or something.
In contrast, the player doesn't need anything from the GUI, right?
Yeah.
The player doesn't care about the model doesn't care about the display at all. So in this case, the GUI knows the player. So the answer is interface again. player. Okay. And what do I need in this interface?
For the GUI.
Yeah, for GUI.
Viewable.
Huh?
Interface one.
Interface. What do I need? It cannot be empty, right? It's empty is useless. What do I need? Like this. Do you agree? Can I make this better? This interface is not yet perfect. right? This GUI doesn't have to be specific to HP, right? It can be used for MP, it can be used for score, right? This can be very general. There's no way to, you don't need to like specify this particularly to that HP, right? In contrast, however, if the GUI of this interface is already designed to be a heart, in that case, because the UI did the artist did it that way. In that case, this GUI can only be used to display HP. In that case, you should do this. I'm not saying that the most general one is always the best. It's the most suitable one that is the best. I never say try to be general at all time. The most general thing you can ever create is a programming language. It doesn't mean you're turning your work as a programming language and you say you finish your job. So you need to be specific. That's your job. Your job as a programmer is to be specific. So be specific to the suitable level. Okay. So just assume in this case, the picture is a heart. So this can only be used to display HP in this case. Okay. So the first takeaway is, before you two separate and work on your own thing, the first thing you must do, is to agree on an interface. First agree on an interface, then you can separate. The interface is the only thing you will have in common. Nothing else you will have in common. So agree on an interface and you can work on separate things however you want. Agree on an interface. So in this case, you agree the GUI knows the player doesn't have to know the GUI. Maybe the player can know the GUI. It's a different story. But in this case, the player doesn't need to know the GUI. So you agree the player is the one who is going to be injected. So you create the interface for the player and ask for only what you need. Okay, you only need the int. That's the only thing you need. You can inject the int gettable, or in this case, the picture is already determined to be a heart, and it can only be used for HP. So then you inject the HP, right? And then what do I do? Then what do I do? Somebody? Somebody? You agree on an interface, and you created GUI. Okay, say I'm the guy writing on GUI, right? What I do is I public display or void display, no parameter, right? And the only code I need to write is print int source dot get int. Then my job is done, right? I'm still waiting for my partner. I'm still waiting for my partner. My partner job is not done yet. It's very complicated. What do I do? I cannot move forward. I want to test my code to see if my GUI is correct.
Just get an int as an input and see what it can display on the screen correctly.
Yeah, basically that is the idea. That's the advantage when you share an interface. You create a dumb class called fake player, okay, or testing player. Testing player. The testing player implements the IHP gettable, right? The only thing you need to do is to implement that get int. getInt function, which you can simply say return 50. Done. It doesn't matter how complicated that player logic is. Maybe the player needs some physics correlation to detect object correlation and to determine how much HP is lost. Maybe the hard punch kills more HP, the soft punch kills less HP. It's super complicated for the player. But once you agree on the interface, you can basically fake the other part for testing purpose, of course, only for testing purpose. So, any comments? Do you like this solution? What do you think?
So what about
go
actually the player doesn't finish and the player GUI finish first?
Oh, you mean that's what I said. That's what I said. You mean the other way?
Yeah, the other way.
You mean
like you want okay. Actually, you just get the data that the interface that are needed. So you're good, right?
Let me try to understand your question. So your question is, what in this case I finish GUI first and the player isn't finished. You're asking what if the GUI is not finished, but the player is finished, right? Is that your question?
Yeah.
Yeah. In that case, you want to test the player, but the player, as we discussed earlier, the player doesn't need to know the GUI at all, so no problem to begin with. The player is never waiting for the GUI because the player doesn't even need to know the GUI. Does that make sense?
Yeah. So we just need to test the data at an output.
Yeah. Then that becomes a different issue. Yeah. Maybe you test the physics correlation things, like maybe you are checking if the thing is adding numbers, subtracting numbers correctly. Then that becomes a different testing. In this purpose, we are testing the coupling with the player and the player GUI. So your question is a different discussion. But good question. Yeah. Okay. We are almost done with our orientation today, so a few more slides. So the takeaway is, when you are collaborating, agree on an interface first. The interface is always, like most of the time, the interface is the answer for my question. So agree on the interface first and work on your thing and try to fake the other guy's part as simple as they can. Okay. So here again, the answer is interface. One class should not know the other class. Okay, so classes should communicate via interface and only interface. You shouldn't reference another class you shouldn't use a class to reference another class. So unless you have some real compelling reason, which I don't think you have. So for example, in this case, again, let's use the player and the GUI example. Say your player has some secret algorithm to calculate the collision, and you don't want to give that to other people, but you are giving out the GUI class to the other people because that's no secret, that's just some picture, okay? But your secret code is your player. Or in this analogy in this slide, if you have a class account and it has a secret password, same idea. But now you need to go back to the player. Now you are giving away the GUI class to other people. You want them to work on it. Maybe it's a independent whatever, make independent part-time somebody to work on it, but you don't want to give out your player to that person. Okay, so if you however, in contrast, if you did this, let me do it. Player is the actual class, not the interface. Player is the actual class. Okay, now you gave away this code to that independent contractor. What's going to happen in terms of IDE, in terms of compiler? You didn't give them the player class. You only gave them the GUI class. You didn't give them the player class. What will happen in terms of the IDE? What's gonna happen? The compiler won't compile. The IDE will complain. The player class cannot be found. Right? If you use IDE, that's what's gonna happen. You didn't give them the player class. The compiler is gonna complain. The player class is not found. Okay, then you just say write a fake class player to them. You are just giving yourself more work to do for no reason. What if the player reference something like a physics engine? Okay, now you need to fake a physics engine. Okay, now the physics engine reference some vector calculus. Now you need to go to fake a vector calculus. So you see this extra work becomes endless. Versus if this is say like iPlayer. Okay, maybe let me go back. Yeah, let's go this. Okay, you just give them the interface. The interface has nothing. Oh, no, not this one. You give them the interface. The interface has nothing. The interface is empty. No secret in there. So you see that's another advantage of interface. In this case, the answer is don't do this. Instead, use like iPassword, which there is only a password interface, and the compiler sees the interface is there. The compiler is not going to complain. Okay. What time is it? Do you want to do this, or this is secondary? Do you want me to do this, or do you want me to prefer me to finish sooner? Give me your options. Either is fine. I'm not going to be offended. If nobody say anything, I will do this. Okay, then yes. Okay, I will do this. So earlier we said that if you use the constructor, if you use this constructor dependency injection, then it can no longer be changed, right? It can no longer be changed, which is a good thing for most of circumstances. That's a good thing. You don't actually want to change it. But now let's take a look at this specific person class. Okay. The person needs to eat food. Okay, so you make a food for the person, right? And you inject that via the constructor. That's basically the constructor. Okay, that's it. Africa, the interface for the food is like this. It returns energy, right? That's it. Okay. Now the problem comes. Remember we said once you inject them via the constructor, it can no longer be changed. The question is, as a person, do you want to eat the same food every day? Probably not. But once you inject them via the constructor, it cannot be changed. So how do you solve that problem? Do you want to inject them? Do you want to eat the same food every day? Probably not. You have an iFood interface. I mean, you can implement that with you can implement iFood with sushi, with beef, with rice, with noodle, with cake, whatever you want, right? Since that's inherited, you can stick all of them into it, right? So what do you do? How do you solve this problem?
Use the settler.
use a setter. Okay, use a setter. That's one solution we gave you earlier. But I didn't. Again, there's no particular preferred method, but in general, okay, if you don't have any extra information, the constructor injection is preferred. Just giving like the most general case, the constructor is preferred, simply because you cannot make the data wrong, right? You cannot change it. There's no possibility to make it wrong. So now I give you additional information for this. Okay, this person doesn't eat the same food every day, but there is a clear pattern for his diet. Okay, so on Monday he eats sushi. Okay, on Tuesday he eats what does he eat? Noodle. Wednesday rice. Thursday pancake. Okay, some just making things up. Okay, given this particular structure, this pattern, can you do something better? Then still use a constructor injection. In other words, you cannot change it. Any guess? Or if nobody say anything, I will give the answer. If you want me to wait, let me know. If nobody say anything, I will start to give the answer. Okay, sounds like I will start to give you the answer. Here is a hint to the solution. So we have this iFood interface, right? I create a class called food locator, which implements iFood, and I inject I'm being sloppy on this, alright? I know I'm doing something horrible, but I know you can read it. I know you can read it, so I'm being sloppy on this. Okay. And of course, most importantly, I need to inject a calendar. I need to inject a calendar, right? I need to know which day today is, right? Since I implemented the iFood interface, I need to implement this function, energy consume, right? I'm being sloppy on this pseudocode as long as you are readable. If calendar is Monday, is that clear?
Yeah.
Any questions? Do you see how this adheres to the single responsibility principle? The person, the only responsibility is to eat. He cares nothing else. The food, those only responsibility is to provide energy, nothing else. This locator is to decide which food to eat, nothing else. And the syntax is all legal because the sushi implements iFood. So sushi has a consume function, right? Sushi has a consume function. And this locator also implements iFood. Therefore, the locator also implements the consume function. But since they are both return energy, I can just return that. Okay? So that's the solution to this problem. Here is another interesting case. Actually, I want you to give me some experience you experienced, right? Some real life experience you had in the past. Think of a time you change your code back and forth, back and forth, back and forth, and back and forth. The same code, just back and forth, back and forth, back and forth. Like, when did that happen and why? You're changing the same code back and forth, back and forth, back and forth. Okay, one simple scenario is that you wrote your code and you think you're wrong, you change it. And you realize you were right to begin with, and you change it back. Okay. So that's the most naive scenario for that. Okay. And another less naive case for that is you are writing a strategy to trade in the market. Okay. So if it's been a good market, you need to set a parameter to like A, B, C, D. Okay, if it's a bad stock market, you need to change the parameter to X, Y, Z, W. Okay, something like that. And there are many parameters you need to change in many parts of the file. Okay, how can you solve this unnecessary waste of your time? It's not that hard.
Use version control tools.
That's one answer. Sure, that is one answer. But that means you cannot move forward. Okay, the answer for this is like this. Do I need to explain, or you got what I mean? That should make it clear, right? Unit testing. How many of you never heard of the word unit testing or not familiar with unit testing? Or how many of you is familiar with unit testing? If you don't say anything, I don't even know if you're still listening. Okay, anyway, we will go into more detail in the real work. But basically, why you should write unit testing is because it makes testing automatic. Okay, it's not that automatic. You need to write the code to test them, but you need to write it once, and every other time the testing will be automatic. In contrast, if you test it yourself, like you might delete your testing code. How many of you delete your testing code? How many of you I'm pretty sure all of you delete your testing code. But why? You wrote that code hard, you spend effort on that, and it's very likely you need to test that thing again. Like there's no reason to delete the code whatsoever. And so you need to do testing anyway. So why don't you do that systematically in an organized way? Okay? The unit testing also makes things fast. Okay? Let's go to the Super Mario example. I'm testing the GUI, right? But if I want to do the full testing, I need to create a player which creates a physics engine to detect the collision. And I need to create a bunch of things just to simulate that GUI. Whereas we already learned there's a hack to do it. Just create a fake player that returns 50. Right, that takes 1 millisecond, versus you would need to initialize a physics engine to do that. So that makes testing fast, and you can inject a fake one for the testing purpose, as I said, and you might change code. That's the first thing we did. The hardest thing to do is to change code, because once you change one code, it might create a ripple effect to affect 10 more classes, and that 10 more classes may create a ripple effect for other 100 more classes, right? So if you change one thing, you're afraid it might crash something else. Only if you have unit testing, you see that before you change everything, all the unit testing passes, and after you change the thing, still all the unit tests still passes, then you know you didn't break something, or at least you have a very high likelihood you didn't break something because all unit testing still passes, right? So that way you are not afraid to change code. Okay, the most horrible thing is when you become afraid to change code, when your code is so fragile, you don't want to change your code. Then we have a big problem. We have a big problem when you are not willing to improve your code. So here is a difference between dependency and the variables. So from a syntax point of view, you cannot distinguish dependency and the variable, right? Because they are just variables. Like technically, they are just variables. So how do you distinguish dependency and the variables? First, you inject dependency. You don't inject variable, right? And the dependency is usually read-only for the reasons we discussed. And when you declare something as read-only, that saves you tons of effort to write those getters, right? It's annoying to write those getters, right? You know that. And when should you inject versus parameterize? So as we discussed, if that dependency, once you initialize it, it will never need to change. It's fixed. Inject it for sure, right? If it's changing in a predictable way, use a injection locator like the sushi, the food example, right? If it changes unpredictably, you can. There are two ways to do it. One, you just do a setter, right? Obviously, a setter, or one you can leave it as a parameter for the function, right? Both are okay. One is better than the other, depends on the specific setting, but okay. Don't expose your dependency path via interface. Okay. Now let's look at this example. Okay. So the system, whatever language you use, C# for example, the system gives you a standard stack. I hope you all know what a stack is. It's a first in, last out thing, data structure. Okay. You write a stack. You want to write your own stack. Let's call it my stack. That keeps change the total push and pop operations. So in other words, it's the second line. You want to create a get total. Basically, every time you push, you add 1 to the counter. Every time you pop, you also add 1 to the counter. So you just want to create an arbitrary stack to keep track of the total operations you get to the stack. And now let's again go back to the Google Doc. Again, create your own space and let's write that stack. Given the stack, remember the standard stack is given. Did everyone leave? Then let's call.
Well, I wonder what to do. I'm a little bit confused.
Okay, first create your name first. Write your name first. That's the first thing you do. Okay, after you write your name, okay, and this is already working on it. No, I don't want you to do. No, I don't want you to do. I don't want you to copy what I do. No, don't copy my thing. No, don't copy my thing. Okay, first go to my code. Go to my code. Do you understand my code? Who doesn't? It's pretty standard. Actually, I think everybody should understand my code. Okay. Okay, this code is given. Okay, you can use it directly. Don't write it again. Don't write it again. My code is given to you. Okay. It's a standard stack. Basically, what I want you to do is actually create a class called myStack, such that you keep track of the total number of times you push and you pop. So in other words, in your class there should be a in your class there should be a counter initialized to 0, right? So every time we call push, the counter goes up 1. Every time we call pop, also goes up 1. Does that make it clear? Now I think it should be clear for everybody. Again, follow the DIY principle. Don't repeat code. Don't repeat my code. You cannot duplicate code with me. Okay? You cannot repeat with me. You cannot repeat my code. It is specific to this instance of stack. So in other words, okay, let me put it this way. In other words, if you create 2 instances of my stack, they should keep track of the numbers separately. It's not a global thing. No global thing. Global thing is horrible. Did I answer your question, Alex? Good. Okay, let me give you a more concrete example first. Maybe then you can understand. Let me put it this way, okay? Disney Park. Okay, you all know Disney Park, right? I created a new Disney Park object, right? The Disney Park has 2 operations: enter the park and exit the park. Okay, so enter park allows 1 person to pass the gate, and the exit the park allows 1 person to exit the gate. And I want to keep track how many people are already currently at this moment in this park. How do I do it? If you are confused, work on this problem instead. No, don't work on this problem. No, it's just that's a way to help. No, don't work on the Disney Park problem. But does that example help you understand my question? Yes or no? Yeah. So basically, in the Disney Park example, I want you to do the basically the number of pushes minus the number of pops. That is how many people in the park, right? But in this case, I want you to add them up to get together. By the way, in this particular example, I want you to be specific on public or private. Label your thing public and private clearly. Label your public and private clearly. By the way, Andy, in this particular example, the system stack is given. You cannot change the given stack. You're probably trying to do that. So when somebody gives you a bad thing, how do you work with it? Tom, your stack should still do the job of a stack. Your push should still do the push. Your pops should still do the pop. It just has additional counter, but your stack is still a stack. Homa, you again misunderstood my question, or you are not familiar with stack. When you call pop on a stack, you only pop one. You are popping everything. Yang Hongzhi, you are not taking advantage of the given stack. You are reinventing the wheel. You are reinventing the wheel. The question is asking you to take advantage of the existing stack. Okay, I see everybody's done. So, my favorite answer is actually Andy's. That is basically exactly the same as the standard answer. So, go to my code. Go to the segment of my code. I actually have a question for you. Here I'm copying Andy's code. Okay. I'm making a change. I'll make it in boldface. What's going to be the problem of this? Or rather, let me make it less. Let me make it less obvious. Okay, so it's still private on this. So suppose this is the suppose I make this change. Obviously that's going to be public, right? Getter must be public. Okay. Suppose I make this change. What's gonna be the horrible consequence? What is going to be the horrible consequence? Somebody? I'm creating a getter, right? A getter doesn't allow data to be changed, right? So it seems fine, right? Or is it?
Well, somebody might get the stack and push or pop on it without counting the push and pop.
Okay, but I use the getter. The getter doesn't allow any data to be changed. So explain more. Explain more in terms of getter that is read only. You're right along the line. Just explain, elaborate. A getter is read only that. A getter is read only, so we all know that. So so basically the takeaway the takeaway message of this is that when your getter is on a reference type, for example in C# everything is a reference type. The getter doesn't really give you any protection power. So the getter is not So here now it comes a question. So if we follow my code to the original system.stack, if you go to the system.stack public So if the original system.stack is super powerful, it does other things like func1, func2, func3, func5, func6. I want you to have a stack that also can. I want you to create a stack that can do everything my stack does, in addition with the counter. How would you do it, and how would you not do it? So now, originally we only have push and pop, right?
Yeah.
So now it says this stack has many functionalities, and I want you to create my stack to do everything my stack does, in addition to have those functionalities.
Directly inherited from the original one.
Okay, inheritance is in this case inheritance is a faster way easier way to do it. But what if, okay, this is a third-party library, okay? They don't want other people to take advantage of their code, and then make it sealed, so you cannot inherit from it. Now what do you do? It's a third-party library stack. They sealed it. They don't want you to steal their code. Okay, do you get what I mean? Okay. This is the ugly way to do it, and it certainly violates the DIY principle, and so far I haven't found a better way to do it. If you do, let me know. But the good news is that there is a good news. The good news to that is, where's Andy? Did you delete your interface? I was going to copy your interface, but anyway. If there is an interface stack, if there's an interface stack that does all the thing, you know. If you do this, if there's an interface stack that does all that, you know what I mean. And you make my stack inherit I stack. Make my stack inherit my stack. The IDE can automatically write this for you. So that is the good news out of bad news. If you inherit I stack, the IDE can do this automatically for you. Okay? So we're always to the end of the orientation, only 3 more slides. Okay? So the solution to the carry on many parameters problem. So for example, there's a make robot function that returns a robot, right? That returns a robot. That returns a robot. You need the arm, you need the leg, you need the body, you need the head. So you call that to make a robot. In the future, you might want to add create glasses. A robot has glasses or something. Then you are changing the function signature, and you need to change everywhere that the function calls. The solution to that is again dependency injection. Okay, and actually I want to finish today, so I will leave this to you as an exercise question. So if you still remember the person eating food problem, on Monday it's sushi, Tuesday beef, Sunday is salad, right? So you can totally expect this if Monday is if Tuesday, if Sunday is structured to appear somewhere else. For example, there's a work class that says if Monday work, if Tuesday work, if Sunday play, right? You should totally expect the same if Monday, if Tuesday, if Wednesday structure to appear somewhere else. And that's clearly a violation of the dry principle. How do you avoid this if that appears everywhere? How do you avoid that? That's going to be a homework for you. And yeah, that concludes my orientation, and thank you for staying with me so late. And before we conclude, do you have any questions? I guess no. Then let's finish. Bye bye. I hope I will see you working for Ampligence, and bye. OK， 那个谢明啊，谢明啊，谢明啊。啊？谁？那个西塔的东西来了。
哇。